We're going to find the area of a regular polygon. Round your answer to the nearest tenth if necessary. So that means that we're expected to have decimals. And if we have decimals, obviously round it to 1 decimal place. So we have this figure. Okay, so we know how to get the area of rectangles, triangles, parallelograms, trapezoids. But now we're going to call a regular polygon. All right, a polygon, basically, we talked about these before. It has a figure with sides that are straight. I gave you guys a list of sides, so we should have this on our notes from before. Right? This is a pentagon. Remember, hexagon is 6 sides, heptagon is 7, octagon is 8, nonagon is 9. So I can give it to you guys in words as well. You guys, by now, you should know the names of the polygons. We have this in previous notes. If you guys don't remember those, you guys can contact me. Send me an email, I can go over with you. So I can do I can give you guys the figures, like I say number 35. I can give it to you guys in words as well. Okay, so I have that I'm gonna call this regular. What regular means is that all the sides are the same length, all the sides on the outside. So I see that one side is 17.6. So I can say this other side here is also 17.6, right? All the sides are equal. Now we're going to find another measurement. It's from the center of the polygon to the center of one of our sides. That measurement, we call them the apothem. Let me write this thing down, the apothem. Now, the name of that side is really not that important. The cool thing about the apothem and the sides is, let me use this in black, is that I can create, I'm going to do this here, from the center to each of my corners, I can create this into triangles. Now, focus on this triangle here. We know how to get the area of a triangle. Don't we go multiply the two numbers that make the 90-degree angle? So in this case, 12.1 times 17.6, and then we divide this by 2, right? That's what we do for triangles. If I do that, that's going to give me the area of this triangle only. But I can do that triangle. The nice thing is that that area is the same as this other triangle, this other triangle. My polygon, I broke it down into triangles. There's 5 triangles in there because there were 5 sides to begin with. So as soon as I find the area 1 triangle, let me multiply this. So my answer, let me multiply this by how many sides the polygon had. In this case, 5. Okay, so I'm just gonna go 12.1 times 17.6 divided by 2, and I'll even press equal here. Right here, I'll press equal, enter, whatever your calculator does. So that gives me 106.48. That is just the area of the one triangle. My result, let me multiply this by 5, and it gives me 532.4. So again, get the area of one triangle, and then multiply by how many triangles you have. The amount of triangles is equal to the amount of sides. All right, let's take a look at number 36. I just want to focus on this triangle. I know this measurement outside is 9.5. Because remember, it's a regular polygon. All the sides outside measure the same thing. You guys can see where I got the 9.5 from. That triangle alone, right? The 9.9 is the apothem, right? So that triangle alone is going to be 9.9 times 9.5 divided by 2. Don't forget we divide by 2 in triangles. And then I'll press equal, enter whatever your calculator does. So it's going to give me my area of the one triangle. And then I'm going to multiply this by how many sides my polygon has. So it has, I'm going to count the sides. Let me use red for counting. There's 1, 2, 3, 4, 5, 6, 7. So I'm going to multiply this by 7. All right, so let me use my calculator. 9.9 times 9.5 divided by 2. It gives me 47.025. That is one triangle. Let me multiply my result by 7. So my calculator gives me 329.175. But my instructions said round it to the nearest tenth, so 1 decimal place. The second decimal place is 7, which is big enough. I'm going to push this over. So my answer, let me type this as 329.2. If it said rounded to the nearest hundredth, 2 decimal places. If it doesn't say about rounding, then type everything out. Now 37, let's take a look. Just want to focus on this triangle. I know this measurement out here is 18.4. So for that triangle alone, I'm going to go 15.9 times 18.4 divided by 2. Right? That's that triangle. Whatever I get, I'm going to multiply this by how many sides my polygon has. So let me count the sides. There's 1, 2, 3, 4, 5, 6. This is a hexagon. It has 6 sides. All right, so let me go 15.9 times 18.4 divided by 2. And I'm going to multiply this by 6. According to my calculator, I have 877.68. Again, for my notes, it says rounded to the nearest tenth. So 1 decimal place. The 8 is going to push the 6 over. So my answer is 877.7. Lastly, let's take a look at number 38. I know this side right here is 16.2 because it's a regular polygon. I'm looking at this triangle only. That triangle only is 16.2 times 14 divided by 2. Whatever I get, I'm going to multiply this by how many sides my polygon has. It has 1, 2, 3, 4, 5, 6. It has 6 sides, so it's a hexagon. All right, so let me go 16.2 times 14 divided by 2. It's 113.4. The one triangle. Let me multiply this by 6. So it gives me 680.4. So here, I gave you guys the information in figures, but I can also give it to you in words. You just need to know how much is the length of the sides, because all the sides are equal. What's the measurement, the apothem? Remember, the apothem is a distance from the center of the polygon to the center of the sides. That's the apothem. And obviously, how many sides there are.